Hi everyone, welcome to DiffCal Calculus. Today we explore lesson 2.2, the limit of a function. Let's begin with number 1, definition and existence of limit. Definition: suppose fx is defined when x is near a number a, then we write limit x approach a fx equal L. This notation means the limit of fx as x approaches a equal to L. Well, if we look at a number A, there are two ways that we can approach that number. We can either do a right approach or we can do a left approach. What this tells us is that in order for the limit to exist, the limit from both approach must be the same. And it's summarized into the existence of limits which say that limit x approach a fx equal to L if and only if limit x approach a on the left side equal L and limit x approach a on the right side is also L. That is left limit. This one is right limit. Let's take a look at how we're gonna use the definition of limit and the existence of limit to compute a few examples. Number 2, limit using table. Example, find the following limit a. We have limit x approach 0 on the right side, 1 over x. So to do this one, you just have to cook up the table. X fx 1 over x approach 0 on the right side. We can begin from 0.1. 1 over 0.1 is 10. Next number is 0.01, getting close to 0. 1 over 0.01, 100. 0.001, then we're going to get 1,000. So as we get to 0 on the right side, the limit of the function is going to infinity. And so this is infinity. For B, we do the same thing. In order to compute limit as x approach 0 on the right side of root x squared plus 9 minus 3 over x squared, we use the table. X and fx is root x squared plus 9 minus 3 over x squared. So we have a 0.1. Do the substitution, and we have a 0.1. 0.01, 0.1, 0.001, 0.1, Well, it looked like as we let x approach 0 on the right side, the limit is going to 0.166, which is exactly 1/6. So the limit here is 1/6. In C, we have limit x approach 0 of psi x over x. From the existence of limit, we got to do two different tables. One for x approach 0 on the right side, and then the other one for x approach 0 on the left side. We do a right limit 0.1, we get 0.9516, 0.01, 0.9950, 0.001, 0.9995. So eventually, as we approach 0 on the right side, the limit is 1. Left limit x psi x over x on the left side of 0 is negative 0.1. Do the substitution. Well, we get the same number, 0.9516, negative 0.01, 0.9950, negative 0.001, 0.9995. So as we approach 0 on the left side, the limit is 1. The left limit and the right limit, both of them are the same. So the limit of psi x over x as x approaches 0 is 1. Oh, pretty cool. Let's move on to limit using graph. By limit given graphs of fx, on example A, we have this graph here. Limit x approach 2 of fx. In order to do this, we got to figure out the right limit and the left limit. Limit x approach 2 on the left side of fx. Approach 2 on the left side is this approach right here. As you see, the output of the function go to negative infinity. Limit x approach 2 on the right side of fx is approach this way. The function go down to also negative infinity, and therefore the limit of the function as x approaches 2 is negative infinity. Limit x approach 1 of fx. Limit x approach 1 on the left side. Approach 1 on the left side, it looks like the function goes to 0. Limit x approach 1 on the right side, the function also go to 0. And so the limit here is 0. Okay, let's move on to example B. We have this graph right here. We want to figure out the limit x approach -1 of fx. Similarly, we got to do the limit x approach -1 on the left side. On the left side is approach this way. So as you see, the output on the left side as x approach -1 is 2. Limit x approach -1 on the right side. On the right side, approach -1 this way. So we have to use the part of the graph that is consistent with approach 1 on the right side. And if you look at the graph, right, the output of the function is approaching 1. Well, left limit and right limit, they're not the same. So the limit does not exist. Or DNE. Next, limit x approach 10 on the left side of fx. Approach 10 on the left side is this way. So if you look at the function, it goes up to infinity. Therefore, the limit is infinity. Thank you for watching. I hope you found the content useful. See you in the next video.